All right, so again, for the second day, we're doing elimination. We're solving systems. Oops. System is anything with two or more equations, right? Anything with two or more equations. And we're solving, right? Solving a system means to find the x and y that works for both. And remember, we talked about how to solve by graphing. And we talked about how to solve by substitution, but now we're going to talk about, again, for the second day, elimination. So let's write those steps down in case we forgot. So the steps are, we're going to multiply to create. We're going to multiply to create opposites. Okay, go ahead and write it down at least this once. Multiply, to create opposites. Then we're going to add straight down. Then we're going to solve. Okay, so those are our steps. Multiply to create opposites. Right, the key word is opposites. Right, you're going to multiply to create opposites. Then you're going to add straight down and then solve. So let's take a look. Number one. So we want to look for opposites. And opposites. 2x, negative 2x. 2x, negative 2x. These are already perfect opposites. We don't need to do any multiplication. Cool, so we're done with step one. All we have to do now is add straight down, step two. So we're going to add straight down. Let's go ahead and add that. So 2x plus negative 2x. These are a zero pair, so we just get 0. And negative y, so let's add straight down here. Negative y, positive y. Negative y and positive y are also a zero pair. This is strange. This is not the normal thing, but we also get a 0 here. Equals negative 6 plus 6. That is also a 0 pair. So negative 6 plus 6, that's also 0. So we finish up, we get 0 equals 0. Now we have talked about this. If you get something with no more variables, x and y went away, if it's true, if it's something true, like 3 equals 3, negative 5 equals negative 5, if it's something true, that means you have infinite solutions. Okay? If it's something true, you have infinite solutions. If it's something false, like 0 equals 5, negative 3 equals 8, something like that, then you have no solutions, right? No solutions. Okay, so which one do we have? Remember, no solutions would be parallel lines, right? No solutions would be parallel lines. What do we have here? Well, 0 equals 0, that is a true statement. That is a true statement. So in this case, we have infinite solutions. You can cross this off. We do not have no solutions. We have infinite solutions. What that looks like, we haven't seen that yet if we graph it. If you graphed it, and this was the red guy, and he looked like this, and you graphed the green guy, and he looked like this, the green guy would be exactly the same graph as the red guy. In other words, every single point they share. This is a solution, this is a solution, this is a solution, this is a solution, boom, 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 boom. They're all solutions because it's the exact same graph. So it's infinite solutions for number one. All right, let's take a look at number three, excuse me. Number three. So number three, again, we want to start off, we want to multiply to create opposites. Multiply to create opposites. Let's look here at our x's and our y's. Which one is easier? Which one already has opposites? Well, if you look at the y's, they're almost, you have positive 2 and negative 1, right? Positive 2 and negative 1. So if you want to multiply this by 2, you get positive 2 and negative 2. But we don't need to do that because, look, the x's are already opposites. The x's are already opposites. So we are done with step one. Multiply to create opposites. We don't have to do that. We can just go ahead and add straight down. Let's go ahead and add. That's a plus sign. Very ugly one. There we go. Plus. Add straight down. So negative 3x plus positive 3x, that is a 0. Again, you could put 0 or you can just put nothing there. And we add straight down here. What do we get if we add straight down? 2y plus a negative 1y. 2y plus a negative 1y. That's a positive 1y. Plus 1y or just plus y. Equals 8 plus a negative 4. Different signs subtract. 8 minus 4 is 4. Take the sign of the bigger number, it's a positive 4. And, oh, we're done. So y equals 4. All right, if y equals 4, all we got to do now is plug into one of the other equations. You can plug it in here or here. Pick which one you like. I like the positive one, so let me just go ahead and do this one over here. Get rid of that. So I'm going to use the second equation, but you can use the first one, of course. 3x plus 2y equals -4. You don't have to write it out. You can just plug it in directly. 3x plus 2 times, and we think y is 4, so let's plug that in. 2 times 4 equals -4. Okay, so 3x. Go ahead. 3x. Let me go ahead and draw my barrier. 3x plus 2 times 4. 2 times 4 is 8 equals -4. Okay, so how do we get the x by itself? We got to get rid of the 3, got to get rid of the 8. Let's get rid of the 8 first. What's the opposite of a plus 8? Is a -8. What switches like that? -8. There we go. -8 on both sides of the equal sign. Here is a 0 pair then. So we get 3x equals. And what do we have over here? Well, that is same sign, keep and add. So 4 plus 8 is 12. -12. And we divide by 3 on both sides. Let's see, we get 3 over 3 makes a 1, so x equals 12 divided by 3. 12 divided by 3 is 4 with a negative sign. All right, so our solution, the point that works for both, be careful, don't put this first. The x comes first when you name your solution. Your solution is -4, because x always comes first, +4. -4, +4. Again, x always comes first in the coordinates, so put that one first. Okay, keep moving on here. Let's go ahead and take a look at number 5. So number 5 here. So number 5. So we look for, again, number 1, we want to multiply to create or to get opposites. Multiply to create opposites. Let's look for opposites either here or here. Do I have any opposites? X and X, those are not exactly opposites. 3y and 3y, not exactly opposites. So we do need to multiply to create opposites. And then don't forget step 2, we're going to add straight down, and then step 3, we're going to solve. Okay, so you could pick either one. Why don't we pick this time, I don't know, the y to eliminate. All right, so what is the opposite of 3y? What's the opposite of 3y? It is -3y, right? -3y. So we want to turn this positive 3y into a -3y. Well, what number is going to multiply to turn this into a -3y? Just a -1, right? So let's go ahead and rewrite this second equation. You could have done it with the first one too. It doesn't really matter. Okay, it's a second equation, rewriting it. Now we need to multiply to create opposites. Let's go ahead and multiply to create opposites. Again, we want to turn this 3y into the opposite, -3y. So multiply by -1. But if you multiply by -1 on this side, you have to multiply by -1 on this side. So what do we get? What do we get? Distribute. -1 times x. -1 times x, -x. And -1 times 3y. -1 times 3y, -3y. Equals. Negative times a negative. What's a negative times a negative? That's a positive. 1 times 1 is 1. All right, so we have just created our opposite. Now, let's go ahead and add straight down, but we have to add the other equation here. So we used, which one did we use? We used this equation right here, right? We used this one. So let's go ahead and put this first one here. You can either put it on top or underneath, wherever you have more space. I can squeeze it in on top, I think, so I'll put it up here. There's no problem if you put it underneath. So if you look here, now we have exact opposites on this y. But wait a second, what's going on here? We have opposites here with x, right? X and negative x. This is a 0 pair also, that's a 0. We also have opposites here, 3y and negative 3y, right? That's also opposites. And equals 3 plus 1. 3 plus 1. If you add that, 3 plus 1 gives me 4. So again, we get 0 plus 0, 0 equals 4. This is one of those weird cases. When all the x's and y's go away, remember what we talked about. If it is something true, like this, 3 equals 3, negative 5 equals negative 5, you have infinite solutions, two lines that are right on top of each other. If you have something false, like 0 equals 5, negative 3 equals 8, whatever, you have no solutions because you have parallel lines that never touch, never intersect. So in this case, ask yourself, right here, is this true, infinite solutions, or is this false, no solutions? True or false? Is this 0 equal 4? Of course not, right? It's false. So we do not have infinite solutions, we have no solutions. In other words, these two, if you were to graph them, would be parallel lines. They'd be parallel lines. There's no point that works for both, right? Solution works for both. There's no point that works for both. All right, let's turn the page over. So we're continuing our elimination practice on the back here. So again, our steps. First off, we want to multiply to create or to get opposites. That's the key word. You want opposites. Step 2, you want to add straight down. And step 3, you want to solve. All right, so multiply to get opposites, add straight down, and solve. So let's take a look here. Number 7. So we want to look for opposites. That's the key word, right? You want to multiply to create opposites. Multiply to create opposites. Well, look here first. Do I have any opposites? Negative, that's a negative 1, and positive 2. Not quite. Not quite. What do we have here? Let's see, that is a positive 4 and negative 2. Not quite, but we could work with that. Either way, so x or y doesn't really matter, but why don't we work with x this time? Right? So I have a negative 1 and a positive 2. What's the opposite of positive 2? It would be a negative 2, right? I want to turn this into a negative 2. I want to turn this whole row, this x, into a negative 2. He's already a negative 1, so let's write that out. So negative x plus 4y equals negative 9. I want to turn this guy into the opposite of positive 2. What's the opposite of positive 2? Negative 2. So he's already a negative 1, so he just needs to turn, he needs a 2, right? Because this is going to turn him into a negative 2, right? Positive 2, negative 2. I'll turn it to negative 2. If I multiply by 2 on this side, I need to multiply by 2 on this side. So distribute. Go ahead and draw the arrows. What do we get? 2 times negative 1x. 2 times negative 1x, negative 2x. That's exactly what we wanted. 2 times 4y. 2 times 4y. 2 times 4 is 8. And 2 times 9. 2 times 9 is 18. But there's a negative in front, right? Negative in front. So we just worked with this row right here. We just turned this row into this. So let's rewrite the second row underneath. I mean, I guess you could put it on top, but he was there to begin with. So there we go. All right, so let's take a look here. We have just multiplied to create opposites. These are opposites. Perfect. We're done with step 1. Now we're going to add straight down. Let's go ahead and add straight down. So 2x and negative 2x. That's going to give me a 0. So you can put a 0 here or just nothing at all. And 8y and negative 2y. So that looks like different signs subtract. Different signs subtract. 8 minus 2 is 6. Take the sign of the bigger number, positive 6y. And negative 18 plus 0, that's negative 18. All right. So now we're going to get this y by itself. We just divide, add my barrier here, divide both sides by 6. 6 over 6 makes a 1, so y equals 18 divided by 6 with a negative in front, right? 18 divided by 6. 6 times what gives me 18? 6 times 3 gives me 18, right? 6 goes into 18 3 times. We get y equals negative 3. Y equals negative 3. Okay, so now we're going to take this and plug in. You can plug in either way, here or there. This is a little bit smaller, so we'll go with this one. So 2x minus 2y equals 0. You could do the top one either way. So 2x minus, be careful here, minus 2 times, we know that y is a negative 3. Looks like we have a negative times a negative here, so we'll work with that. Let's figure out our x, whatever. So there's my barrier, so 2x, a negative times a negative. A negative times a negative is a positive, so negative 2 times negative 3 is a positive 6 equals 0. Okay, I want to get rid of this 2, I want to get rid of this 6. Get rid of the 6 first. How do I move that 6 over? What's the opposite of positive 6? Negative 6. So that gives me a 0 pair right there. So we get 2x equals 0 take away 6. 0 take away 6, that's just negative 6. Almost done. Just divide both sides by 2. Now let's do this extra equal sign, which I don't need. So go away. There we go. So 2 over 2 makes a 1, so x equals 6 divided by 2, that's a 3 with a negative in front. So what do you know? They're both equal negative 3. So my solution, remember put x first, negative 3 for x, negative 3 for y. This is the point where these two are going to meet, negative 3 for x and negative 3 for y. If you plug that in, I'll just do that in my head. So here, negative times a negative 3, so that's a 3. 3, and then 4 times negative 3 for y. 4 times negative 3 is negative 12. So 3 minus 12. 3 minus 12 is negative 9. That works. Let's see, 2 times negative 3, that's a negative 6. Negative 2 times negative 3. Negative times a negative is a positive. So negative 6 plus 6. Negative 6 plus 6. Negative 6 plus 6 does equal 0. So it does work out. So this works out for both. So it is the solution. Let's do a couple more here. Number 9. All right, so we want to, step 1, multiply to create opposites. Look here and here. Who is easier to make opposites? Well, you've got 5 and negative 1. It'd be pretty easy to turn this into 5 and negative 5, right? 5 and negative 5. This guy just needs to multiply by 5. If you go with the y's, which is also fine, you'd have to think about what number does 2 and 3 both go into. 2 and 3 both go into 6, right? So you'd have to multiply this guy by like a 3, this guy by like a negative 2, because then you get 6 and negative 6, right? 6y and negative 6y. That's a little bit more work. So we'll stick with the x's because look, they already have the positive negative thing going. All right, so we want to multiply to create opposites. So we got 5x. Let's turn this guy into negative 5x. So we're going to work with this one right here. So let's go ahead and write it out. We want to turn that guy into a negative 5x. Negative 5x. He's already a negative 1, so we don't need a negative. We just need to multiply it by 5, right? Because that's going to turn him into a negative 5x. That's exactly what we want. But if you multiply this side by 5, you have to multiply the other side by 5. Maintain your balance. So we get, if we distribute here, negative 5x. It's going to be multiply here. That's going to be 15y equals 9 times 5. Well, 10 times 5 is 50. So 1 less 5. 50 minus 5. 9 times 5 is 45. Okay, so that was this equation here. Now I'm going to put this guy, you can either put him on top, where he was right here on top, but I'm kind of low on space here. I'll put him underneath, so it doesn't really matter which way it goes. Equals negative 11. All right, so we're done with step 1. We have multiplied to create opposites, because look, these are perfect opposites, 5 and negative 5, 5x and negative 5x. Perfect, so we can do step 2. That is add straight down. Add straight down. Let's add straight down. We get 5 and negative 5. That is just a 0. You could put 0 or nothing at all, a blank. 15y plus 2y. 15y plus 2y. 15 plus 2, 17. And 45 minus 11. So 5 minus 1 is a 4. 4 minus 1, 4 tens minus 1 10 is 3 tens, and the positive team is stronger, so it's a positive 34. Cool, so I'm just going to ignore this 0. How do I get y by itself? Well, I'm just going to have to divide by 17. Divide both sides by 17. This becomes a 1. So y equals, what is 34 divided by 17? How many times does 17 go into 34? Well, I'm thinking it's 2. Let's make sure. 17 times 2. 2 times 7 is 14. 2 times 1 is 2, plus 1, 3. Yep. So that's going to give me y equals 2. Y equals 2. Once I've got that, let's go ahead, plug it in. I'm just going to plug it into either one, but I like this top one because there's less negatives here. So we get 5x plus 2y equals negative 11. But we think y is 2, so we're going to plug that in here. So 5x plus 2 times 2, right, we think it's here, equals negative 11. And now we plugged it in. Let's go ahead and solve for x. So let me draw my barrier here. So 5x plus 2 times 2 is 4 equals negative 11. All right, how do I get x by itself? I got to get rid of the 5. I got to get rid of the 4. The 4 is going to come first. How do I get rid of a positive 4? What's the opposite of positive 4? Negative 4 on both sides of the equal sign. 4 minus 4, that makes a 0 pair. So we get 5x equals, that looks like right here, same sign, keep and add, so 11 plus 4. 11 plus 4, 15, but we keep the signs, that's negative 15. Okay, go ahead and divide both sides by 5. Divide both sides by 5. And we are going to get 5 over 5 is 1. So x equals, let's see, 15 divided by 5. How many times does 5 go into 15? 5 times 3 is 15, but there's a negative in front, so x equals negative 3. Excellent. So our solution, where do they cross? They cross when x equals negative 3. Remember, the x always comes first, and y equals 2. Right? X always comes first. X equals negative 3, and y equals 2. This is our solution. That's the point where they cross if I was to graph this system. Okay, very last one of demonstration. Okay, this is kind of the challenge one. It's the challenge one, so be ready for it. Step one, let me erase this here. We want to multiply to create opposites, right? That's the whole key here. Multiply to create opposites. Let's look here. Are these opposites 4 and 3? No. If you wanted to create opposites, what number does 4 and 3 both go into? They both go into 12. So if you wanted to shoot for like 12x, negative 12x, you could do that. But you'd have to multiply by like 3 and negative 4. You have to multiply both of them by something. Let's see if y is a little bit easier. I think y is a little bit easier because look, you already got a plus and minus thing going. You got the plus and minus thing going, so we're going to pick the y. We're going to pick the y. But what number here, what number do they need? What number do both 3 and 2 go into? 3 and 2 both go into 6. So I'm going to turn this into 6y, sorry, negative 6y. Turn this into negative 6y. I'm going to turn this into positive 6y. So unfortunately, we need to multiply both the top and the bottom. I need to turn this into negative 6y. I want to turn this into positive 6y, right? They both need work, so we're going to have to multiply both of these guys. So let's start with this top guy. 4x minus 3y equals 2. This guy needs to turn into negative 6y because otherwise I can't create opposites, right? So let's multiply. What do I need to turn this into a negative 6? Well, I already have negative 3. So 3 times what gives me a 6? 3 times 2. So let me multiply both sides by 2. Let me distribute here and here. So 2 times 4x, that's 8x. 2 times negative 3. 2 times negative 3. Positive times a negative, that's a negative 6. And 2 times 2 is 4. Okay, so before we used to always just be able to take this other guy and put him underneath, but if you look, 2y, that's still not the opposite of negative 6y. I need to turn this 2y into a positive 6, right? Because if I turn this into a positive 6y, then I'll have positive 6 and negative 6. So let's take this guy, this bottom guy, let's take him over here. We've never done this before. We have to multiply both top and bottom by something. Okay, so I turn this into negative 6. I want to turn this guy into a positive 6. So let me use the green. What does 2 need to turn into a positive 6? 2 times what gives me 6? 2 times 3, right? But if I multiply the left side by 3, I have to multiply the right side by 3, otherwise things are unbalanced. So what do we get? Let's distribute here. Distribute. 3 times 3 is 9x. 3 times 2 is 6y. And 3 times 10 is 30. Whew. So the red and green, these are my two guys. Let me put them together. Let me put the red guy, or the green guy underneath here. I'm just going to copy him underneath. 9x plus 6y equals 30. 9x plus 6y equals 30. Because look, now, finally, after multiplying both top and bottom, we have opposites. Negative 6, positive 6. Right? Negative 6y, positive 6y. So we are done with step 1. All of that was step 1. So step 2, now we can finally add straight down because we got these opposites. So 9 plus 8. 9 plus 8x. 9x plus 8x. 9 plus 9 is 18, so 9 plus 8 is 17x. And of course this is a 0 pair, so you could put a 0 or just nothing. 30 plus 4. 30 plus 4, 34. Oh, cool. So this is exactly what we had before. 17x equals 34. Right? We know if we divide both sides by 17, right, the 0 just kind of goes away. Divide both sides by 17. 17 over 17 makes a 1. So x equals 34 divided by 17. We just did that over here. 17 goes into 34 2 times. So x equals 2. And once I have that x equals 2, I can plug into any of these guys. I'm going to pick the smaller one here, and I'm going to pick this guy, the bottom one, because he's a little bit smaller, and so he's a little bit more positive. The top guy has some negatives. So let me rewrite that. 3x plus 2y equals 10. But I think x equals 2, so let me plug that in. 3 times 2 plus 2y equals 10. So finish this problem off. Let's solve it. I get 3 times 2. What is 3 times 2? 3 times 2 gives me 6. 6 plus 2y equals 10. I want to get rid of the 2. I want to get rid of the 6 to get y by itself. Let's get rid of the 6 first. What is the opposite of 6? Negative 6. This makes a 0 pair. So 2y equals 10 minus 6. What is 10 minus 6? 4. Divide by 2. Divide by 2. We get y equals 4 divided by 2, or 2. So our solution, x is 2, y is 2. X is 2, y is 2. That is the equation. That's the point that works for both. If you were to graph these, they will cross at x is 2, y is 2. And let's just check that in our head. If you plug in a 2 right here and a 2 right here, 4 times 2 is 8. 3 times 2 is 6. What is 8 minus 6? 8 minus 6 is 2. That works. Plug this in right here. Plug in a 2. Plug in a 2. What is 3 times 2? 3 times 2 is 6. What is 2 times 2? 2 times 2 is 4. What is 6 plus 4? 6 plus 4 is 10. That checks out. So 2, 2 is our solution that works for both.